talking about isosceles triangle theorems and other methods of proving triangles are congruent. So we're going to learn the rest of our congruent triangle postulates today, actually. So, a couple of vocab things. We ready? We have our notes out. We're paying attention. Excellent. So, we're going to start off with 4.4, which is isosceles triangles. We've learned a little bit about them. Okay, but we're going to get a little bit more into it today, and we're going to have some proofs with them. So, a couple vocab things for an isosceles triangle. We have a few different parts that we're going to need to be able to identify. The first one is the legs of an isosceles triangle. Are we paying attention, gentlemen? We're looking at our computers and then looking at each other, so that tells me we're probably not paying attention. I don't know, you keep glancing at your computer and then looking at Kason for some reason. Maybe you just like looking at Kason, I'm not sure. Or maybe you're avoiding eye contact with me, not sure. So, the legs of an isosceles triangle, those are the congruent sides of an isosceles triangle. So the two sides that are congruent, those are called the legs. So that's a leg, and that's a leg. So in this situation, that would be segment AB and segment AC. Those are the legs. Then you have the base. The base is just simply the third side. Nothing really special about it. Okay, that is the base. That's BC. Then you have base angles. The base angles are the angles on either side of the base of the isosceles triangle. So like the ones on either side, the left and the right in this situation. That would be angle B in this case. So angle B and angle C, those would be your base angles. Something you'll notice, which we'll get into in one of our corollaries down below, aren't they marked as congruent? Why might those base angles be marked as congruent? Nick? Yeah, exactly. They're opposite those two congruent legs. That's going to make those base angles congruent as well. And then you also have a vertex angle. That is the angle opposite the base of the isosceles triangle. It ends up being the angle that's not congruent to the others. So this is your vertex angle. Okay. So those are your main parts of your isosceles triangle. Then we have our isosceles triangle theorem, which you actually already know, you just don't know it as a theorem. But it just says if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So this is where that comes from, where if you know that segment AB and AC are congruent, then angles B and C are congruent. You can also use it the other way around. If the angles are congruent, then those sides opposite them are congruent. So either way it works. Either way, it's still the isosceles triangle theorem. Okay? So also if you know B and C are congruent, you would know AB is congruent to AC, which would then make it an isosceles triangle. Then we have a few corollaries. Remember, our corollaries aren't going to have like nice fancy names, but we can still use them in our proofs. And you're welcome to, like abbreviate and kind of like shorten these up a little bit if you need to, if they're long. And these should also sound familiar. An equilateral triangle is also equiangular and vice versa. And an equilateral triangle has 360-degree angles. We've talked about both of those, but it's nice because then you can use that in a proof. So if you're dealing with a proof with an equilateral triangle, you could like go ahead and state things about their angles and their sides and things like that. And then the last corollary is that the bisector of the vertex angle of an isosceles triangle is perpendicular to the base at its midpoint. So what that means is if you have an isosceles triangle, okay, the bisector of the vertex angle, remember that's going to be the one that's not congruent to the other two. So that would be this angle here. If you have a segment bisecting it, that bisector is perpendicular to the base. In other words, it's going to be perpendicular to the opposite side. So you would have something like this. Okay? Any questions about our definitions or corollaries? Should sound reasonably familiar, yes? Okay. All right, so we are going to just practice applying some of these things. Okay. Did you need me to scroll up to anything, Sebastian? No? Okay. Okay, so solve for the variables. How these diagrams are going to look is you're going to have to notice maybe some different sides that are congruent, different triangles that are occurring. Maybe you'll need to use that the sum of the angles of a triangle is 180, right? Maybe you'll need to use a linear pair. There's going to be some different information you need to remember here. So we're going to solve for our variables. We have actually a few different things happening here. Isn't this whole overall triangle a right triangle? And then see in here, don't we have a little isosceles triangle happening within that? Yeah, so there's a few different measurements occurring. We got to figure out what both X and Y are. What I would maybe do in something like this is start to, don't just automatically be like, okay, I got to solve for a variable like right now. Look at your picture and be like, well, what do I know? What are some things I could maybe label? What's some additional things I could deduce from what I'm given? Sebastian? Mm-hmm. Yeah, 140. Yeah, but that's exactly, yeah, like up here. Isn't that angle going to have to be 140? Definitely. Okay. That's the kind of stuff I would probably start to label. Will it always be helpful? No, but could it be? Yeah, maybe. What's something else you might notice, Matt? Exactly. It's isosceles, right? So if those two sides are congruent, if the bottom right is X, the bottom left is also X. Well, yes, Sebastian. Yeah. So now at this point we can solve for X, right? Because all three angles have to add up to be what? 180. So if you want, you could set up an equation for that, or you could just like subtract by 180 and divide by 2, however you feel more comfortable doing it. But here, I'm just going to show you as like an equation. You would do x plus 140 equals 180. That's going to give you 2x equals 40, and then x equals 2. You don't have to do it as a formal algebra equation like that. If you prefer, and you just notice, oh, okay, well, 180 minus 140 is 40. That has to be split up evenly. I was wondering why Ella was looking at me funny. Just tell me next time, Ella. I'm writing numbers all day. I'm bound to forget one eventually. So, do that and divide by 2. Whatever you feel more comfortable with, okay? Well, now I know that. I'm actually gonna use that information. I'm gonna erase that. I now know that this angle is 20 and that angle is 20. What could I maybe do now, Ella? Yeah, I now know that angle 70. Oh, bless you. Why is that helpful? Oh, sure, yeah, Ben. Exactly. I have a y, a 40, and a 70. If I take x plus 40 plus 70 equals 180, or add them up and subtract, right? Again, however you want to do it. That would give me 110. 180 minus 110 is 70. Good, yes. What do I do now? Oh. I told her to tell me. I want you to tell me. My second block let me check an entire homework assignment with the projector off. We went over an entire worksheet and the projector was off the whole time and no one told me. It's like, how have you been checking? And there was graphs. I'm like, what are you? We've been listening to the numbers you're saying. Oh, okay. Sure. Sure. Okay. Like I can't like from here, I don't notice. Gotta tell me. Anyway. Does that kind of make sense, guys? Okay, so let's look at B. This one, we have an equiangular triangle over here, and an isosceles. It looks like it could maybe be a right angle, but can we assume? Like a right triangle? Can we assume that? No, I wouldn't assume that, though. Any ideas? What are some things we could just start labeling based off what we know? Ella? Yep, all these angles are going to be 60. That's definitely something we know. Good. What else? Matt? Yeah, okay. All of these are going to be the same, so they're all going to be 5y, right? Okay, good. What else? I'm just going to leave it with the congruent marks or else it's going to get really cluttered. Logan? This one on the inside here? Yep, absolutely. I see one more thing I could probably label. Sebastian? Not necessarily. It might be, but we don't know. But you could do something with that lower angle there. Ben? Where? Doesn't y equal, oh yes, y will equal 4. Yeah, we'll talk about that in a second. I thought you were, yeah, I don't know. Yeah, this other angle equals x. Okay. You don't have to label all those things right away. I just think why not get them out of the way, right? Okay, so Ben, how did you know that y equaled 4? Yeah. Yeah. Yeah, exactly. If this bottom one is 5y, that's 5y, right? And this guy here equals 20. So yeah, those are equal. Set them equal. 5y equals 20. So y equals 4. Good. All right, how am I going to figure out x? Sebastian? Mm-hmm. Yep. 30, right. That's okay. All right, so here, because yeah, you know that all of these are going to add up to be 180. So x plus 120 equals 180. That's going to give you that 2x equals 60, and then you should get 30. Good. Very good. And then this last one. This last one's a bit tricky. Where could we start? Let's just start again. Start labeling your information. Braden? Yeah, good. This one here. One day I'm going to learn how to write a neat 3 on this thing, but probably not today. Good, that would be 31. Excellent. Ella, what else? Yeah, we'd have our linear pair, right? Good, that would be 121. Sebastian? Good, how can I solve for x now? Very good, yep, I have this little triangle within my larger one. So add those up, 121 equals 180. That would give me x plus 166 equals 180. Subtract that over to get 14. Thank you. I wanted to say 24 at first, and I was like, that's not right. All right, good. Y is the trickier part. Not tricky, you just gotta like look at a couple things first. Matt, what are you thinking? Very good. Yes. You need to use the information you just found, right? This angle here, X, is 14. And if you add up 14 and 31, that's going to give you a 45-degree angle up here, which makes that congruent to that angle down there, which makes this an isosceles triangle, right? Matt, you felt like you were so proud of yourself that you figured that out. It takes a second sometimes to look at it, but you gotta, so we see the 45 and the 45. So now we know that these two sides here are gonna be congruent. What would be a proper way to set up an equation for that? Logan? Good, but what do I do with this side? I'm confused, it's separate. What do I do with that? Logan? Yeah, just add them together. That's just an easy place to make like a weird mistake to forget about one part of it or something, Sebastian? Yep, exactly. Yep, 4y minus 3 equals 2y plus 11. So you should get that 2y equals 14 and that y equals 7. Good. How do we feel about those? They're like little puzzles. I would just start by just writing down information, right? Don't be like, I have to figure out a variable right away, right? Label it and then see where it takes you. Okay, good. We just have one proof for this part. I kept it short. It was more to be able to just talk about some of our new theorems, okay, that we learned. So in this proof, we are given that angle 4 is congruent to angle 7 and that angle 1 is congruent to angle 3. We want to prove that triangle ABC is isosceles. Now, in order to prove that it's isosceles, think backwards. What are you going to have to be able to show? The tricky part about isosceles triangles, specifically in its definition, it's very specifically says that 2 or more sides are congruent, right? So we're going to have to show 2 sides are congruent. But in order to show 2 sides are congruent, you might have to show 2 angles are congruent first, right? You might have to kind of work towards that. So I'm given, and instead of like putting my arcs, I'm going to highlight them just so it doesn't get too cluttered. 4 is congruent to 7, and 1 is congruent to 3. Let me zoom in over here a little bit. How could that maybe help us? You got to kind of think back to an old thing we talked about. So for this one, 4 and 7 are congruent. 1 and 3 are congruent. So Logan said that 4, I'm sorry, not 4, B and C. Huh? Yeah, yes, Sebastian. It's actually that angles B and C are just congruent to each other. Does anyone remember what it's a corollary that we talked about last quarter? Ashley? Exactly. It's okay, Sebastian. Oh, not trying to prove the two. Right. Yeah. Okay, yes. So we want to say angle B is congruent to angle C. And that is a corollary. And that corollary is kind of like, it's kind of a mouthful, right? It's kind of a long one. I have a tendency to refer to it as just the third angle corollary. L-L-A-R-Y? Spelling is not my jam. That's what I mean, you can write it all out if you want. If I write that, does that make sense to you guys? It's just a really long one to write out. Good. So now we know B and C are congruent. Why would that maybe be helpful? Ella? Exactly. Segment AB is going to be congruent to segment AC. How come? What's our reason? Ella? Yep, good. Isosceles triangle theorem. Good. And now, if the two sides are congruent, is it an isosceles triangle? Yeah. So triangle ABC is isosceles. That is the definition of isosceles. Good. Make reasonable sense? Great. All right, onward. All right, so now we have two more theorems for showing triangles are congruent. They're actually our last two. And then you'll be able to use these interchangeably with like side, 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 angle, side, all those things. Hypotenuse. In a right triangle, the side opposite the right angle is called the hypotenuse. Does that sound familiar to you guys? Good. And then the legs of a right triangle, those are just the other sides. Okay. All right, so we have two more theorems, angle, side, angle, angle, side, and hypotenuse leg. Angle, side, angle, if two angles and a non-included side of a triangle are congruent to the corresponding parts of another triangle, then the triangles are congruent. So in this situation, you have your two triangles here. Angle C is congruent to D, E is congruent to F, and segment BA is congruent to segment EF. So we have a set of congruent angles, another set of congruent angles here, and then in this case, it's the set of not included sides. So it's going to be a side that's not in between them. Do we kind of notice the difference between this and angle, side, angle? Right? If it was angle, side, angle, it would be CA and DF. In this case, it's not. And then hypotenuse leg. Remember when I told you there's no ASS theorem? Here it is. No, I told you it only happens if, huh? Of course I did. Well, I didn't. I mean, the geometry community did, I guess. Because I told you guys, I don't know if you remember or not, it only works for a right triangle. So this is the only kind of triangle it's going to work for. You would have a set of congruent angles in your vertical angles, and LM is congruent to MP, and LN is congruent to OP. So if you take a look here, yes, it looks like angle, side, side. However, it only works for a right triangle. So there's going to be a few different things that you have to look at for this. You have to have a congruent hypotenuse. That has to happen. That's where the H comes from in hypotenuse leg. So you have to have a congruent hypotenuse. In this case, that would be LN and PO. And you have to have a congruent leg. That is LM and MP. And you have to know it's a right triangle. So you have to know that you have right angles, okay? It won't work if it's not a right triangle. So we're just going to practice identifying these. State which congruence method can be used to prove that they are congruent. These aren't all just the first two like new ones. There might be one from last time on here as well. I want you guys to take a second, see if you can figure out which ones they are. Remember, there is side, 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 angle, side, angle. Now there's also angle, angle, side, and hypotenuse leg. And I'm going to tell you that there is one that does not work. What are we thinking about A? Sebastian. ASA, how'd you know? I don't see a side marked as congruent. Yeah, you have a shared side right here. So it would be angle, side, angle. Very good. What about B? Ella? No congruence. You will have a set of vertical angles here, right? But if you take a look, isn't that angle, side, side? Will that work if it's not a right triangle? Nope. So this one is a no or none or however you wanted to say that. Yes. Where? I don't know why they marked it. Well, I guess so then I guess it also wouldn't work because they're also not their corresponding parts don't end up being congruent. So either way. Logan, you had your hand up. Oh, well, so that's actually another thing. Says if you look at this triangle, that's I think like what David was asking. I didn't notice that at first, but if you look at this one, this looks like an angle side side, and this one is a side angle side, so that wouldn't work regardless. Like it doesn't have the same information matching up. You know what I mean? Oh, I don't know. No reason in particular, I don't think. Just the way the diagram was drawn. Yeah, and they won't always be drawn to scale either. So like if two things are marked as congruent, even if they don't look congruent, you kind of got to assume with it. All right, what about for C? Ella? Good. Hypotenuse leg. First of all, is it a right triangle? Yes, so that box is kind of checked, right? Then you have a shared side that's going to be congruent. There's your hypotenuse. And then your leg is that other set of sides. So this is hypotenuse leg. And then what about for D? Someone besides Ella. No offense, Ella. Julia? Angle, angle, side. Good. Yep, because you have your shared side. Good. How do we feel about those? Which one are we confused about? Okay, so for B, one way to look at it, Sebastian, if you look at this one here, isn't this marked as angle, side, side? And isn't this one marked as side, angle, side? So that couldn't work anyway. They don't have they don't have proper corresponding information. Okay, Ben, what about for you, hon? You had one that you weren't sure about? Uh-huh. Oh, okay, so something that, yeah, so something that might help you if you find yourself doing that a lot, Ben, is actually like label inside of your picture. So here, like the one arc and the one arc, there's one set of A's, right? And then the shared side is an S, and then the set of two arcs is an A. And then if you actually have it labeled, it should be like written almost in order. Does that kind of help a little? Okay, you're welcome. All right. We got two proofs to look at, and then we will be done. This first proof is very short. The reason I'm giving it to you is look at your picture. What's weird about your picture? It's weird, but what specifically is weird about it? Okay, it kind of looks like a boomerang. Why does it look like a boomerang, Julia? Well, the middle kind of looks like a weird diamondy shape, right? But aren't you trying to prove that triangle RPS is congruent to triangle RTQ? Aren't they overlapping? That's kind of weird. You're going to see that happens occasionally, especially in this section. If you are given something like that and you're just like, well, what's what, right? It can look a little confusing. What do you think you could do to kind of help you with that? Logan? Yeah, that could totally work. You could totally color code it. That always helps me. Ella? You could also redraw it and separate it, whatever you prefer. So for this, like this triangle, you have a triangle here. And they don't have to look perfect, right? They're obviously not going to because I'm drawing them on this tablet. So there's one of them, that's RSP. And then you'd have another one over here, and that's RTQ. And that kind of helps if you separate them out a little bit. And you're given that RS is congruent to RQ, and then angle P is congruent to angle T. So now, once you separate it, isn't it kind of easy to see that you have one set of congruent sides and one set of congruent angles? You just either need another set of sides or another set of angles to prove that these are congruent. Anyone see a place where they might have a set of angles or sides that work, Julia? Why? Very good. It's just kind of like a shared side, but it's a shared angle. If you take a look, doesn't this have angle R in it? Doesn't this have angle R in it? Isn't that also where they overlapped originally? Yeah. So angle R is going to be congruent to angle R. Then what theorem are you going to be able to use to show they're congruent, Ella? Yes, we'll use reflexive property for R. Good. And then what do we use to show the triangles are congruent? Julia? Is the side between the two angles or is it a not included side? Well, so if you take a look at this, the side that connects the angles, like from the two congruent ones, is RT and RP. But those ones we don't know. It's actually not between the two congruent angles. Does that kind of make sense, guys? That part is always a little confusing when you're identifying it. If this was angle side angle, it would have to be RP and RT because that's where those two angles connect. Do you kind of see that, Julia? Okay. And then we're done. So that's all we got to write. So let's put in our given and such. RQ is congruent to RS, and angle P is congruent to angle T. That is given. Okay. Then we're going to say that angle R is congruent to angle R because that was shared. So that's the reflexive property. And then we can say the two triangles are congruent. That's RPS. It's congruent to triangle RTQ. And that is angle, angle, side. Okay. This all making sense to you, Jonathan? Excellent. All right. Last thing, and then we will be done. So here we are given that segment MN is congruent to segment CN, and that angle or segment, point N bisects angle DL. I gave us another bisector because that I remember that one kind of threw us off a little bit last class. Oh, sorry. So this is given. And it says we need to prove angle D is congruent to angle L. Okay, we got to show a set of angles is congruent, specifically these two. In order to show those are congruent, what are we going to have to prove first? Braden? Very good. We are going to have to show that those two triangles are congruent. And once we've done that, will all their corresponding parts be congruent? Perfect. Okay, let's see if we can figure that out. So we're actually already given some information, which is always lovely. We have a set of congruent sides to start with, right? NM and NC. So there's one already for us. What else do we now know? Ella? I'm sorry, could you repeat that? Okay, yeah, we could go there next. How do you know that? They're vertical angles. Are we absolutely welcome to do our vertical angles next if we want to? Sure, let's do that. Why not? Order in these is kind of doesn't matter, which is nice. So angle MNL is congruent to angle M and L, and then you would call the other one CND. And that, you said that is a vertical angle theorem, correct? Okay, perfect. Good. Okay, so now we have a set of congruent angles. What else? Matt? Very good. We have a bisector, right? But remember, segment bisector is a little tricky. Segment bisector provides us with the midpoint, and then the midpoint will provide us with the congruent segments. So we're going to say N is the midpoint of segment DL. That is the definition of a bisector. Good. Now that we have our midpoint, what can we say now? Julia? Yep, DN and LN, right? Segment DN is congruent to segment LN. That is the definition of a midpoint. People online, how are we doing so far? You guys are so quiet. Okay, good. Making sure we're still there. All right, so almost done. Do I now have enough information to say the triangles are congruent? Absolutely. So we can then say triangle DNC is congruent to triangle LNM. When I name those, can I put the letters in any old order I want? No, make sure they correspond. Okay, I don't care how you put the first one, make sure the second one matches. What theorem? Stay with me for like 30 seconds, guys. Ella? Side angle side. And then how can we now say that angle D is congruent to angle L? Nick? Corresponding parts of congruent triangles are congruent. CPCTC. Excellent. How do we feel about this stuff, guys?